Hello students. So we have already studied the structure of an atom and nucleus, isotopes, isobars and isotones. Now let's study in detail about the radioactivity phenomenon. So this radioactivity phenomenon, it was first studied by a scientist named Henry Becquerel in 1896. So what he has done is, he had taken a little amount of salt in a photographic plate, and then he wrapped this completely with a black paper. So he has taken a little amount of salt in a photographic plate which was completely wrapped in the black paper. So the black paper was the cover here. So after few days, he saw that this photographic plate was completely affected. So now he conducted the same experiment with the other salts of uranium. Again, he got the same observation. The photographic plate was again affected here. So this means that here the salts which he has used here and the other salts of uranium, so this had produced or emitted some amount of radiations. So this has produced some amount of radiations. So this radiations, okay, he named it as the Becquerel rays. And later he found out that there were three different types of Becquerel rays, that is the positive rays, negative rays, and the one that is having no charge. So there were three different types of rays. One is positive rays, one is negative rays, and the other one didn't have any charge. So later these were named as alpha, beta and gamma. So this is how you write alpha, this is how you write beta, and this is gamma rays. So here the salts which was used here, so these salts were called as radioactive substances. So these salts, they are called as the radioactive substances, or which is also called as natural radioactive substances, and the other name for this is unstable isotopes. So unstable isotopes you have already studied in different types of isotopes, correct? So these substances, correct? So these substances, these are the elements which is having different isotopes, okay, and these isotopes should have atomic number more than 82, or here number of neutrons should be more than that of protons. Number of neutrons should be more than that of protons. So this is about the radioactive substances. Now let's study about this nature of radiations. How is it produced? So these radiations, they are produced because of the radioactive decay of the elements. So radioactive decay means here the nucleus, which is basically unstable, they lose energy, they lose some amount of energy when they are emitting some sort of radiations. So this is called as the radioactive decay. So what about the nature of the radiations which is coming from the radioactive substances? Basically, this do not change the nature of the radiations. They do not change, or they are not produced by any kind of physical change. So as you know, physical change is nothing but the change of states of matter. Okay, this doesn't change because of the chemical change. So chemical change like heating, freezing, then any kind of magnetic fields applied, chemical treatments, oxidation, reduction, any kind of reactions, or change in temperature or pressure. So all these are nothing but the chemical change. So this change will not occur because of change in temperature or pressure. So basically the nature of radiations, they do not change based on the physical change, chemical change like heating, freezing, chemical treatments, chemical reactions, oxidation reaction, reduction reaction, magnetic field, etc. And also they do not change because of change in pressure or temperature. That means we can conclude that so any changes which is happening in the orbital electrons, they also do not change the nature of radiations. So change in orbital electrons also do not result in the change in the nature of radiations. Hence, we conclude that this is a nuclear phenomenon. This is a nuclear phenomenon. That is because of any changes that is happening in the nucleus, it will result in the change of nature of the radiations. So basically, this radioactive decay is nothing but it is because of the changes in the property of the nucleus of an atom. Correct? So because of this changes, there is a spontaneous emission of alpha, beta and gamma radiations. Correct? So this is because of the nucleus in an atom. So as these substances, they have many atoms in it, right? So a substances means it has many atoms in it, correct? So because of this many atoms, we cannot predict that which nucleus has undergone the change. We cannot predict that which nucleus has undergone the change. So because of this, it can also be called as a random phenomenon. So this can be called as a random phenomenon. So any changes in the nucleus of an atom, that means the nucleus is unstable. The nucleus is unstable. So because of this, some sorts of radiations are emitted, which are alpha, beta and gamma radiations. So basically, this is a property of the nucleus. Hence, we can call it as a nuclear phenomenon. As this salt contains many atoms, right? So we cannot predict which atom or which nucleus has undergone the changes. So because of this, it is called as a random phenomenon. Now, in 1903, the same phenomenon, it was studied by Rutherford. So here, he again studied the nature of radiations. That is nothing but the spontaneous emission of alpha, beta and gamma rays. So what he had done is, he had taken a lead box which was completely covered and there was a small hole. So in this, he had taken a little amount of salt. Now this is a lead box and this is a salt. Now there were few changes. That means there were radiations which was emitted from this. Correct? So what he had done is, so this is the path of the radiations. Correct? So perpendicular to the path of the radiations, he had given, or he had applied a magnetic field. He had applied a magnetic field. Okay, so because of this magnetic field, there were few changes. So some went straight, okay, and some were deviated. So some were deviated, okay, and the others were deviated, one to right, one to left, and one went straight. Okay, so these are the again three different types of radiations. Okay, so as you can see here, one has turned to left, correct, and it has less deviation, and one has turned to right, that has more deviation. Correct? So here the first one here is the one that turns left. Okay, the other one is that is turning to right, and the third one, there is no changes or no deviation. Correct? Now the one that is turning left, that has less deviation. Correct? Here you can see it is having less deviation than this one. So the one that is turning right, that is having more deviation. Correct? So the one that is turning to the left is called as the alpha rays. The one that is turning to the right is called as the beta rays, and the one without no deviations or no change is called as the gamma rays. So the alpha rays is the positive one, beta rays is the negative one, and gamma rays is having the zero charge. So the third one, that is the one that is having no deviations or no change or no charge, these are called as the electromagnetic waves. So these are called as the electromagnetic waves, which are similar to the light waves, So the gamma rays are called as the electromagnetic waves, which is similar to the light waves. So these are not affected by any kind of magnetic field. So this is about the magnetic field. So you have seen the magnetic field, correct? So the same experiment, it was conducted with the electrical field. Again, he had taken the lead box in which he had taken the salt. So from this salt, again, here he had put a negative plate here, a negative charge plate, and here he had put a positive charged plate. Okay, so this again, as the path of the radiation is like this. Okay, so this was again, the electrical field was again perpendicular to the path of radiation. So the radiations are emitted in this path, and perpendicular to this path, the electric field was applied. Okay, so again here he could see some changes, the same changes. Some radiations got deviated to negative charge, some got deviated to the positive charge, and some went straight. Correct? So again you can tell here, the first one, it turns to left. That means on the left side there was a negative plate kept here, correct? So that there was a negative plate which was kept here. That means the opposite charge, that is the positive charge, was attracted to the negative plate. So the positive charge is the alpha particles. So the second one is the other one, that is turning to the right. So on the right hand side there was a positive plate which was kept. So again the positive gets attracted by negative. So again this was carrying a negative charge, which is nothing but the beta rays, correct? So here the beta is more deviated than alpha rays. It was more deviated than alpha rays. And the third one, you can see it went straight, correct? So that means no deviation, that means no charge. It is not attracted to positive charge or negative charge. That means it was not carrying any charge. That means it was having a zero charge, or there was no changes at all. And this was called as the gamma rays, which is again called as the electromagnetic waves, which was again called as a electromagnetic wave. So this is the gamma rays, this is the beta rays, and this is the, this is the alpha rays, beta rays and gamma rays. Again same observation.